So for section 1-2, the negation of a statement P is also a statement called not P. What does that mean? That means if not P is true, then P is false, or vice versa. This is called a truth table here. This is the symbol for not P. So if P is true, not P is false. And if P is false, not P is true. That's pretty much what you would expect, just sort of given the way our language works. Okay, let's take a look at the next page here. There's a theorem that says the negation of a universal statement. So in other words, if you have a universal statement here that says for all x that are part of S, some property applies, the way you make that not true is by saying there exists some x in S such that the property does not apply. Okay, so this is the negation of this. If this is your statement, this is the not this statement. Okay, that sounds a little silly, but here's the example. All prime numbers are odd, right? That would be written as for all prime numbers x, x is odd. And in order to get the negation of that, all I have to say is there exists a prime number x such that x is not odd. All right, that is pretty much it. Okay. Right, and informally, you're familiar with the informal way. If I just say, all prime numbers are odd, well, all I have to do to negate it is say at least one prime number is not odd. Okay. I don't think there's much of a problem figuring out how to do this informally. I think we do this all the time. The question is, how do we do it formally, and how do we do it with the notation? This says let S be a set and P of X, in other words, the property that applies to X is a property that may or may not be true for elements in X, right? So that would be the statement that says there exists an X in S such that the property applies. And if I wanted to say, not true, I would have to say, well, for all x in S, the property does not apply. So again, here's the negation. Some triangles are isosceles. There exists a triangle in the set of triangles such that the triangle is isosceles. In order to disprove that, I would have to say, for all triangles, that triangle's not isosceles, or no triangles are isosceles. That would be the negation, right? Some triangles are isosceles. No triangles are isosceles, right? There exists a triangle X such that X is isosceles. For all triangles X, X is not isosceles. Okay? That's the negation. It's easy to do it informally. The tricky part is to rewrite it in terms of a universal statement or an existential statement. Okay, here. It gets even more complicated if you're trying to use two variables here, but let's just sort of do this as an example. The statement is, everyone trusts someone. Well, we're basically talking about two different people. One of them is everyone, and the other is someone else. Everyone trusts someone. We don't say else here. Here's the solution in words, right? How do you negate it? Everyone trusts someone. The negation is, there is someone who does not trust anyone. that would be the negation. The formal analysis says, for all people X, there exists a person Y such that X trusts Y. What does that really mean? Hey, for everybody, for all people, there exists another person such that the first person trusts the second person. How do you go, no? You say, there exists a person X such that for all people Y, X does not trust Y. There is somebody whom for all other people, that person doesn't trust them. That's what this is. And you're basically changing the property of these two people into not the property of these two people. This says the property is for every X, there is a Y that X trusts. And this says, no, it's not true that for every X, there is a Y that person trusts. Okay. So here they give you sort of the algorithm, the template. In general, the negation of a statement can be generated by reading the statement from left to right and changing for all to there exists, and changing there exists to all, right, one way or the other, and exchanging P X comma Y to not P X comma Y. All right. So again, up here, the formal analysis. For all people X, there exists a person Y such that X trusts Y, and this is saying swap them, right? This becomes there exists. This becomes for all. You put such that in here, and you take such that out of here, and you turn X trusts Y into X does not trust Y. So this is the template of how to do that. But rather than memorize the template, you're probably better off just understanding what it is it says. So let's go through covering the reading questions. If a given statement is true, then its negation is false. True or false, the negation of a universal statement is another universal statement. No. Right? In order to negate a universal statement, I only have to find one counterexample. Right? The negation of a universal statement is an existential statement. If I say everything is this, you only have to say, one thing isn't, and that negates it. True or false, the negation of for all states S requires a driver to have a valid driver's license. Well, if that's not true, then there exists a state such that S requires a driver. Wait a minute. This says for all states it requires a driver, and this says there exists a state such that S requires. That's not the negation. This would have to say there exists a state S such that S does not require a driver to have a valid driver's license. So this is not the negation. That's false. The negation for the statement every person can drive a car is no. There exists a person who cannot drive a car. All fractions are rational numbers? No, there is a fraction that is not a rational number. Number 6, there exists a real number x such that the sine of x is equal to the cosine of x. The negation of that would be no. For all real numbers x, the sine of x is not equal to the cosine of x. This says there is one number x. Okay? I'm thinking of a number, and that number has a sine of that number that's equal to the cosine of that number. And if you want to correct me, you would say, no, you're not. For all numbers x, the sine of that number can't be equal to the cosine of that number. That would be the way to negate this. Number 7, for any statement P, not P is equivalent to, well, this is, I like ice cream. I do not like ice cream. Okay, so I think if I say if I do not like ice cream, then it means I do like ice cream. The statement P, right? If you say not P, well, that's equivalent to P. Right? If this is true, not P is false, and not this false thing means P is true. Right? If this is true, not P is also true. So P and not P are equivalent. All right, multiple choice. The negation of some quadratic equations have 3 solutions. Notice it doesn't really matter whether this is true or not. We're talking about how to negate it. If I say some quadratic equations have 3 solutions, it's not enough to say some of them don't. I didn't say, right? I didn't say all of them do. I just said some of them do. So if you find some that don't, that doesn't mean anything. If you say all quadratic equations have 3 solutions, that sort of proves my point, because if all of them do, then some of them do. If I say there are some that have 3 solutions, and you say no quadratic equations have 3 solutions, that's the negation of that, and vice versa. The fact that there exists a quadratic equation with 3 solutions actually is the same as this one. There is some quadratic equation that has 3 solutions. There exists a quadratic equation with 3 solutions. I imagine you could become a little bit more formal or technical and say, well, no, if I say some quadratic equations, that means more than one. So maybe you could say these two are not equivalent statements, but they're certainly not negations of each other. What else have we got? Let's go over here. All right. To negate the existential statement, there exists an x in S and a y in T such that they have this relationship. Well, to negate the existential statement, change this to for all, right? The upside down A. Delete the words such that here, and change this to not this. So instead of saying there exists an x and a y such that they have this property together, I would say for all x and y of these particular sets, then not this is true. Write the negation of the following statement. There exists a function f such that for all real numbers a and b, the function of the two added together is equal to the function of a plus the function of b. Right? There exists a function f such that for all real numbers a and b, f of a plus b is equal to f of a plus f of b. So what would the negation of that be? If there exists a function, right? If I'm claiming there exists a function that for all real numbers a and b, this is true, in order to negate that, I have to say for all functions f, there exists real numbers a and B such that f of A plus B does not equal f of A plus f of B. Okay? So basically what this says is there is such a function that for all real numbers, A and B, this property is true. And what I'm saying is for all functions, there is a pair of real numbers A and B such that this is not true. Right? I'm saying for all functions, right, there is some pair of real numbers A and B such that it's not true. That means that there can't be one where it is true all the time for all real numbers. And finally, the statement, everybody loves somebody, right? Write this statement in the form, for all people, there exists a person such that this person loves that person. For all X that's an element of people, there exists a Y that's an element of people such that X loves Y. The negation of that statement is, nope, there is a person X that's an element of the set of people, right? Right? There exists such a person such that no such that for all Y that's an element of people, X does not love Y. Right? So if I say everybody loves somebody, the negation is no, there is somebody who doesn't love anybody else. Right? So there exists some X that's an element of the people. There exists a person such that for all other people, X doesn't love them. That would be the negation of that. That's the covering the readings set for section 1-2.